Okay, so now we're going to talk about the shape of the Earth and how it's not actually a perfect sphere. So let's assume that this apple is the Earth. As it spins around its axis, the spinning here creates a centrifugal force. Just like when you're on a merry-go-round and you feel yourself being pulled away from the center of it, that force is also being applied to everything on the surface of the Earth. What this does over billions of years is it's actually pulled the equator, where the force is the strongest, away from the center of the Earth relative to the poles. So while the poles might have remained more or less the proper radius from the Earth, from the center, as if it were a perfect sphere, everything around the equator has been stretched outward and widened. And you can kind of visualize that in the shape of an apple. It's a little bit fatter than it is tall. This is true for the Earth. It's a tiny, nearly imperceptible difference, but there is a difference there, and it's why the circumference at the equator is actually slightly larger than the circumference of the Earth if you went from pole to pole and around. And this will impact navigation ever so slightly. We'll get into more detail on this later. When you're doing things like Mercator sailings, you need to be able to take into account that warping of the normal curvature of the Earth and how it's going to change courses and distances. For the time being, though, it's important that you just keep this in mind and understand why that warping is present.